Hello students, how are you? Hope you are doing well. Now the question is, explain briefly with the help of label diagram the basic principle of the working of an AC generator. Coil of n turns and area A rotated at an angular velocity omega in a uniform magnetic field B. Derive expression for instantaneous value of the EMF induced in the coil. What is the source of energy generation in this device? So this is the particular problem. So यहाँ पे हमें कहा गया है कि हमें एक्सप्लेन करना है द बेसिक प्रिंसिपल ऑफ द इलेक्ट्रिक जनरेटर विद द हेल्प ऑफ द लेबल डायग्राम की हेल्प से। ऐसा जनरेटर जिसकी n नंबर ऑफ टर्न्स की कॉइल है और इसका एरिया a है और ये रोटेट हो रहा है एंगुलर वेलोसिटी ओमेगा से एक पर्टिकुलर यूनिफॉर्म मैग्नेटिक फील्ड के अंदर। इसमें हमें एक डेरिवेशन भी करना है इंस्टेंटेनियस वैल्यू ऑफ ईएमएफ का डिपेंडिंग अपॉन द गिवन पैरामीटर्स, और साथ ही साथ हमें ये भी बताना है व्हाट इज द सोर्स ऑफ एनर्जी जनरेशन इन दिस पर्टिकुलर। सो द सॉल्यूशन ऑफ दिस प्रॉब्लम इज AC generator is a device which converts the mechanical energy to the electrical energy. So it is basically a converter of mechanical energy to the electrical energy. Now the basic principle. The basic principle of the generator, electrical generator, is the electromagnetic induction. Basically, electromagnetic induction takes place. So we can say that it is based on the principle of electromagnetic induction. Now, working. So here is the diagram. There are two poles of this particular magnet. Concave, it is having concave section. In between there is a coil, rectangular coil, and there are certain number of turns of this coil. This is basically the frame, and on this frame there are coils. There are number of turns. So when a closed coil is rotated rapidly in a strong magnetic field, the magnetic flux linked with the coil changes continuously. So this is the coil here, and in between there is magnetic field. The magnetic field lines goes from north to south pole. So when this particular coil rotates, the flux changes. There is a change in flux, and the presence of magnetic field is there. So the magnetic flux linked with the coil changes continuously, hence an EMF is induced. And when there is a change in the flux, then we know that there is a generation of EMF. So an EMF is induced in the coil and the current flows in it. In fact, if the mechanical energy is expended in rotating the coil, appears as the electrical energy in the coil. So basically, it is a conversion of the mechanical energy to the electrical energy. The mechanical energy can be obtained from various forms. For example, it may be a hydro energy. For example, some water is flowing over the turbine and the turbine is rotating. So the turbine is getting the mechanical energy from the force of the from the water, from the flow of water. So there may be many reasons of there may be many source of generation, many type of source of generation. Now let us see the construction of the electrical generator, the main parts of the electrical generator. So the first main part is the armature. The first main part is the armature of the electrical generator. It is a rectangular coil. It is a rectangular coil ABCD as shown in the diagram earlier. It is having a large number of turns of insulated copper wire. So there are number of turns of the copper wire on this particular armature to increase the flux, because we know that E equals to d phi by dt and basically n d phi by dt. So when we increase n, the EMF increases. So to increase the EMF, we use the large number of turns, and they must be insulated with each other so that no short circuiting will take place. The use of soft iron core is also there, and it increases the magnetic flux. To increase the magnetic flux, we use the soft iron core here in the armature section. Now come the field magnet. So field magnet is it's a strong electromagnet having concave pole pieces N and S, that is north and south. Armature is in between and rotate in between these particular poles. And the pole pieces are having an axis perpendicular to the magnetic field. Their axis lie perpendicular to the magnetic field, so that maximum flux produces. Now the next part is the slip rings. The leads from the armature coil ABCD are connected to two copper rings R1 and R2 called the slip rings, and these are concentric with the axis of the armature coil and rotate with it. The next part is the brushes. Brushes are two carbon pieces B1 and B2. They remain stationary. They remain stationary, pressing against the slip rings R1 and R2 respectively. Brushes are connected to the external circuit, that is the load part. Now let us explain the working of the electrical generator. So in the electrical generator, there is a coil ABCD. The coil ABCD is placed inside the magnetic field, and when this particular coil is rotated inside the magnetic field, an EMF is generated across its two ends. Let us assume that at t equals to 0, the plane of the coil is perpendicular to the field. For example, these are the two faces of the magnet. In between, there is the particular coil. So we can say that initially the plane of the coil is at right angle to the magnetic field at t equals to 0, and angular speed of the rotation of the coil is omega. So when angular speed is omega, then theta, that is angle, equals to omega into t at a certain time of t. Now we know that flux, the magnetic flux phi, is given by phi equals to b dot a. Phi equals to b dot a is the value of the magnetic flux. B dot a means ba cos theta. Now theta is omega t, so we can say that ba cos omega t. Now the number of turns of the coil are n, so we can say that it is n ba cos omega t. This is the value of phi. And we also know that the flux is basically is related to the EMF. Now EMF is given by the negative rate of change of flux. EMF is negative rate of change of flux. So it is minus d phi by dt. So we take the derivative of this expression and place the negative sign in front of it. So after taking the derivative of this expression, we pull out the quantities which are not changing. The constant quantities we pull out of the derivative. So the constant quantities are n, b, and a. The number of turns are fixed, the magnetic field is fixed, and the area of the rectangular frame of the coil is fixed. So only quantity which varies with time is cos omega t. We take the derivative of cos omega t. The derivative of cos omega t is minus sin omega t, omega minus sin omega t, because here omega is also there in front of t. So it is omega sin omega t. And the negative sign, it cancels because there is already a negative sign. So negative negative cancels and we get the positive quantity n ba omega sin omega t. Now these four terms are fixed, n ba omega, these are fixed. So we can say that this is the maximum or the peak value of the EMF. So we can write down the expression as E equals to E naught sin omega t, where E naught is equal to n ba omega. This is the peak value of the EMF. Now we can also calculate the current flowing in the load part by using the Ohm's law. Ohm's law states that V equals to IR. So we can say that I equals to V upon R. So V means voltage, voltage means E naught sin omega t. So the current is E naught sin omega t upon RL. This is the value of the current in the flowing in the particular load part. Now this particular diagram shows the orientation, different orientations of the coil at successive time intervals, successive time instants. So this is the particular uh, magnet. In between there is a coil. Coil is rotating. These are the different time instants. These are the different movements of the coil. For example, the orientation of coil is like this: A, B, C, D. Then with the EMF is 0. Then the coil rotates, we get this EMF. Then the coil rotates, we get this EMF 0. Then the coil rotates, we get the negative EMF, and so on. So a complete cycle is obtained. So this is the whole working of the electrical generator, and it is basically a converter of the mechanical energy to the electrical energy. Now let me explain the whole thing in Hindi also. यहाँ पे हमारे पास एक कॉइल है ABCD जो रोटेट कर रही है मैग्नेटिक फील्ड के अंदर. जब वो रोटेट करती है तो एक सर्टेन टाइम इंस्टेंट पे, जब उसका प्लेन परपेंडिकुलर है मैग्नेटिक फील्ड के, उस समय को हमने मान लिया टाइम t इक्वल्स टू 0. फिर एक लेटर टाइम t के लिए हमने कहा t इक्वल्स टू थीटा इक्वल्स टू ओमेगा टी यहाँ पे. और फाई फ्लक्स जो है, फ्लक्स को हमने लिखा, फ्लक्स बेसिकली होता है एन बी ए कॉस ओमेगा टी. फ्लक्स इज बेसिकली b dot a, and b dot a means ba cos theta. Theta is omega t, so we can say that ba cos omega t. और यहाँ पे क्योंकि नंबर ऑफ टर्न्स n है तो यहाँ पे हमने n भी प्लेस किया है. फिर हमने इसका डेरिवेटिव ले लिया बिकॉज वी नो दैट ईएमएफ इज माइनस डी फाइव बाई डी टी, और डेरिवेटिव हमारा ये एक्सप्रेशन आया एन बी ए ओमेगा साइन ओमेगा टी। यहाँ से हमने एन बी ए ओमेगा को जो है फिक्स मान लिया, ये क्योंकि ये कांस्टेंट क्वांटिटीज हैं इसके अंदर, सारी की सारी ये टर्म सारे कांस्टेंट हैं। सो दिस इज ई नॉट इक्वल्स टू एन बी ए ओमेगा। और यहाँ से फिर हमने लोड पार्ट में उसके बाद करंट निकाल ली बाय ओम्स लॉ। ओम्स लॉ स्टेट्स दैट वी इक्वल्स टू आई आर, और या हम कह सकते हैं आई इक्वल्स टू वी अपॉन आर। वी है यहाँ पे ईएमएफ यानी ई नॉट साइन ओमेगा टी, और आर है यहाँ पर हमारा लोड रेजिस्टेंस आर एल। सो करंट जो है वो जो फ्लो हो रही है वो हो रही है ई नॉट साइन ओमेगा टी अपॉन आर एल। सो दिस इज द एक्सप्रेशन ऑफ द करंट फ्लोइंग इन द लोड। सो होप आपको इस प्रॉब्लम की पूरी एक्सप्लेनेशन समझ में आई होगी। थैंक यू।